Welcome to the LMS system. The program is for BSc students who have taken the subject mathematics, and this session is for 6th semester students, and session is third session. The title of the paper is transportation problem and assignment problems. So in this session, today's topic is aim and assumptions of transportation problem. Recap of previous sessions. In the last sessions, we have formulated a transportation problem. That is how it will be formed, we have seen. Now, session outcome. At the end of the session, that is after the completion of this session, we can able to define the types of TP, that is transportation problems, the existence of a feasible solution, and what are the assumptions and aims of this transportation problem. Here, the aim of the transportation problem. So to solve any problem, there should be some aim. So what is the aim of this transportation problem? To find out the optimal transportation schedule, keeping in mind cost of transportation to be minimized. We have to schedule the transportation in such a way that the transportation cost should be minimized. That is, to transfer the goods, product from one city to another city, it should be scheduled in such a way that the cost should be minimized. Right? This is the first aim. And second one, the origin of a transportation problem is the location from which shipments are dispatched. That is the origin. From where the transportation is there, from where it should be, the product from where we have to, it should be known to that. This should be known. Right? Now, next one. The destination of a transportation problem is the location to which shipments are transported. That is the aim of that one. The goods, the product should reach to the destinies, from where it has to start and from where it should reach. That is where it should go. Starting point and ending point, that is the source, and the destination should be known. That aim should be there to reach that. Now next, the unit cost. The unit cost transportation is the cost of the transporting one unit of the consignment from an origin to the destination. So this means as the units, number of unit increases, the cost of the each unit also going to increase. So now there are some assumptions in the transportation problems. So what are that assumptions? The total quantity of item available at the different sources is equal to the total requirement at a different destinations. What does it say? That is, supply is equals to demand. What is this? The total quantity of item available at different sources. That means if a warehouse has 10 quantities, at the same time the retailer demand should be 10. That means supply and demand both should be same. This is assumption, but in some problems there might be, it cannot be like this, but in real problems, but we have to assume here, assumptions are there to solve the transportation problem. We are assuming that supply and demand are same, but in reality it may or it may not. But we have to assume to transportation problem, to solve the transportation problem, we have to assume that supply and demand are same. Now, next one, item can be transported conveniently from all sources to destinations. That is, item can be transported from convenient, it should be, we can able to supply that good from source to destination. We have to assume that we can easily, we can transport that one. Now, the unit transportation cost of the item from all sources to the destination is certainly and precisely known. What is this? That is the unit transportation cost of item. That means a unit, if you want to transpose a product from warehouse to the retailer, the each unit cost we should know that one. That is, as we have seen that figure C11, C12, that is the unit cost. What is the cost of the unit to transfer from one point to another point? We should know that, right? That is C1, indirectly we can say. Next, the transportation cost on a given route is directly proportional to the number of units shifted on that route. That means, what is this? The amount is directly proportional to the quantity, how much you required. It is directly proportional always. The cost will depends on how much quantity you required. Transportation cost on given route is directly proportional. The cost will be directly proportional, right? Now, the object is to minimize the total transportation cost for the organization as a whole and not for individual supply and distribution center. That means we are going to calculate, or we are going to minimize the total cost, right? We are going to minimize the total cost of the transportation, and it is not for an individual or for a distributor or for a supplier. Overall cost we are going to reduce this. That is, we have to minimize that. That is our aim. Now, next, so existence of a feasible solution. What is this? If we can say that there exists a feasible solution for a transportation problem if total supply is equals to total demand. As I have told that if a wholesaler has a warehouse, as if a warehouse has 10 quantity and a retailer shop need 10 quantity. That means warehouse stock is 10 and a demand, that is a retailer has also need 10 quantity. That means total supply and total demand are same, they are equal. Then we can say that feasible solution exists for the transportation problem. That is, the source, supply and the demand should be equal always. Now, types of transportation problem. It depends on whether total supply is equal to total demand or not. If the total supply is equal to the total demand, then the problem is called as a balanced transportation problem. What is, if this summation of demand and summation of supply are equal, then we say that balanced transportation problem. That is, total sum, it might be in different cities, different places, and we have to send it to the different points and different cities. If you make the sum of it, overall quantity of a single product we are talking, if they are same, that is supply and demand are same, then the balance, the transportation problem is balanced. So here we can take an example. In Delhi we have 10 oxygen cylinders. In Bangalore we have 10 oxygen cylinders. Chennai have 10 oxygen cylinders. In 3 cities, 10 equal. There are 10 cylinders and 10 cylinders are there, oxygen cylinders. The hospital at Bangalore, the hospital at Chennai, the hospital at Bombay requires 10 oxygen cylinders. Now, if you add how much quantity of warehouses or how much quantity of cylinders are there with the cities, there are 30. What is the demand, hospital demand? What is the demand at the hospitals? They are also 30. So, supply and demand both are equal quantities. Then I can say that it is an balanced transportation problem. And the second one is unbalanced transportation problem. If the summation of demand and summation of supply are not equal, then we say unbalanced transportation problem. Think that a warehouse 1 has 10 quantity and warehouse 2 has 10 quantity. How much quantities are there in warehouses? 20. If the demand at one point is some 10 and another is demand is 20, 30, that means we have totally overall we have in warehouses 20 quantities are there, whereas demand is for 30. So it cannot be, it cannot solve. So that type of problems are called as a unbalanced transportation problem. So thank you friends.